In this video, we're going to look at another example of inverse variation. Again, just paying special attention to the wording of the question. So let's have a look at the example. A quantity y varies inversely with the square of quantity x. When x equals 10, y is equal to 35. Calculate the value of, so part A, y when x equals 22, and part B, x when y equals 100. So I did a video recently where we looked at variation compared to or relative to the square of another quantity. Okay, so this one's kind of a similar thing, but it's inverse variation. So it's going to involve a fraction. First of all, let's come up with our variation equation. So this is going to be in the form y equals k over x squared. Okay, so it's an abstract example. There's no context to it. Although interestingly enough, this particular scenario is in fact used in many applications, especially in physics. So we call this the inverse square law, by the way. So I've just kept it generic and abstract for now. So let's solve for k first of all. Okay, so y is 35 when x is 10. Okay, so 35 is equal to k over 10 squared. Okay, and solving for k, so k is equal to 35 multiplied by 10 squared, so that's 35 times 100. Okay, so k is equal to 3,500. Okay, so therefore the variation equation is y is equal to 3,500 over x squared. So when x is equal to 22, okay, so I might just, okay, y is equal to 3,500 over 22 squared. Okay, let's evaluate that expression over 22 squared, and we get 7.23. Let's just keep it to 2 decimal places. Okay, so that equals 7.23. Now part B, find the value of x when y is equal to 100. So we just need to solve the variation equation. Actually this one here, in fact, since we've found the value of k. So y is equal to 100, so that's 100 is equal to 3,500 over x squared. Okay. So rearranging this formula, okay, so we have 100x squared is equal to 3,500. Okay, dividing both sides by 100, of course. So in fact, x squared is equal to 35, so it sort of works out nicely. Okay. Not quite 36, so it's going to be a value slightly under 6. Now, we don't know whether x is positive or negative. So in fact, I'm going to quote both answers. It's not a distance. We don't know what x is. So x could be a positive, x could be a negative. So it doesn't really matter at this point. So x is equal to, in fact, plus or minus the square root of 35. Okay, so square root of 35. And we get 5.92. Okay. For x is equal to plus or minus 5.92. It is possible to have situations where there are negative quantities involved. Potentially, we don't know. It really just depends on the situation. Very rare. That doesn't really happen very often where we get situations like that, but this is just a generic case and an abstract case, so I'm just going to quote both answers. But most of the time, the context is usually around something to do with a length or a power intensity or something like that, and so we're dealing with positive quantities.